In today's lesson, we are going to be talking about how we can go about solving quadratics. Now, in particular, we're going to first look at how we can solve quadratics by graphing, and then we're going to look at 4 different ways we can solve quadratics algebraically. So let's start by solving quadratic equations graphically. So here's an example. X squared minus 6x plus 8 equals 0. Now, if we were to put this into the calculator, we would put our x squared minus 6x plus 8 all into the y equals. So let's go ahead and do that. Now after we've graphed it, we can see that in this particular example, this graph passes the x-axis in 2 places. So that means for this example, we have 2 solutions, and those 2 solutions are where the x-intercepts are. So here's my graph, and these 2 points are going to be my solutions. Now how do we go about solving where those intercepts are? Well, we go into the calculator, and if you click on second and then trace, which brings you to the calculation menu, scroll down to 0. So we are actually trying to find the zeros of this equation, right? This is where y is equal to 0. Now there are 2 of them. I'm going to first find the left one. So when it asks for a left boundary, it's asking you to give a boundary to the left of the 0 you want it to find. So I'm going to give the left boundary here. And then it's going to ask for a right boundary, so I'm going to move this until I get past it. And then I'm going to hit enter. And then depending on the calculator, sometimes it may ask you whether or not to guess. And it will guess that it is trying to find the one between those 2 boundaries, and that's the one at x equals 2. You can do the same process again to find the second x-intercept. And we get x equals 4. So those are my 2 solutions here. X equals 2 and 4. Here's our next example. We have x squared minus 3x equals negative 4. Now, unlike the first example, this one has things on both sides of the equation. What we want to do is we want to move everything over to one side so that we can put that entire thing into the y equal. So in this case, I would move the minus 4 over to the left, and we would have x squared minus 3x plus 4. And graphing it, we will have a parabola, but this parabola does not have any x-intercepts. In this case, this means that there are no real solutions to this equation. So that's how you would solve quadratic equations graphically. You're looking for x-intercepts. If there are no x-intercepts, then you would say there are no real solutions. Now, in terms of solving quadratic equations algebraically, there are 4 different methods that we are going to go over. So the first is factoring. The second is taking the square root of both sides. We have completing the square, and we have using the quadratic formula. Now let's start by going over factoring. So in factoring, we actually use what's called the zero product property. So in other words, if you have 2 numbers that multiply together and it equals 0, then A equals 0, or B equals 0, or both could be solutions. All right, so in order to solve a problem like this, you have a number of different solutions. Either the first factor equals 0, the second factor equals 0, or they could both be equal to 0, and that would still, A times B would still be equal to 0. Now let's just go over the process of factoring. So we have here 3x squared minus x equals 10. So first thing you want to do is you want to move everything over to the left. So we're going to subtract the 10 over to the other side. Now the next thing we're going to do is we are going to split the middle. So since we have 3 terms here, we can split the middle, and the first thing you want to do is you want to multiply the a value and the c value. So 3 times negative 10, which gives us negative 30. Now I'm going to draw an x over here on the over here to the right, and I'm going to write negative 30 up at the top. Next, I'm going to write the coefficient of the middle term, and that is negative 1, and I will write that on the bottom. Now, for the other two sides on the left and right, I'm trying to find two numbers that will multiply to negative 30 and add to negative 1. In this case, this would be negative 6 and positive 5. That's how we are going to split the middle term. So now going back to the equation here, 3x squared minus x minus 10, we're going to keep the 3x squared and we're going to keep the minus 10, but the negative x I'm going to split into two terms, negative 6x and positive 5x. After you've split the middle term, the next thing you want to do is you want to factor by grouping. So you're going to take the first two terms and you're going to factor out the GCF. In this case, that would be 3x. You take the last two terms and also factor out a GCF. That would be a 5. So you're left with 3x times x minus 2 plus 5 times x minus 2. Now if you've done this correctly, the terms that are inside the parentheses should be exactly the same. So now we can write this as 3x plus 5 times x minus 2. Now that we've written it as two separate factors, we can set each of these equal to 0 and solve. So 3x plus 5 equals 0 gives you x equals negative 5/3, and x minus 2 equals 0 gives you x equals 2. And so those are your two answers that we've gotten for our equation here by factoring. The next method of solving a quadratic equation algebraically is to take the square root of both sides. Now when you do this, you want to make sure you get the x squared term by itself first before taking the square root of both sides. This way it eliminates having to deal with the square root of, say you had a 2 in front of the x squared. If you took the square root of both sides, then you'd end up with a square root of 2x squared, and you'd have to deal with the square root of 2. So it's easiest if we start by trying to get x squared by itself before you take the square root of both sides. Here's an example. We have 3x squared equals 9. So the first thing I'm going to do is I'm going to get that x squared completely by itself. So I'm going to divide both sides by 3. That leaves me with x squared equals 3. Now the other thing you want to remember when you do take the square root of both sides to solve is that when you take the square root of both sides, there are actually two answers. Right? Think of this. What values of x will make this true? Well, whatever value you get in there, it could be positive or negative. Once you square it, it will become positive 3. So when you solve, you want to make sure when you take the square root of both sides, you get both the positive and the negative solution. In this case, plus or minus the square root of 3. Alright, the third method of solving quadratic equations algebraically is completing the square. So before we get into an example, I'm going to first outline what the steps are. So first, you will write the equation in this form, x squared plus bx equals c. Notice how, first, the x squared term does not have an a in front of it, so it's just x squared by itself. Then we have bx, and then c is on the other side. So unlike graphing and unlike factoring, you do not want to set it equal to 0. You want to have the constant term by itself on the right. In the next step, you will add b over 2 squared to both sides so that the left-hand side is now a perfect square and the right-hand side is going to still be a constant, but it will be c plus b over 2 squared. Then you'll take the square root of both sides and then simplify. Don't forget that when you do take the square root of both sides, that you want to make sure you include both the positive and negative answers. Let's take a look at an example. We have 2x squared minus 6x plus 1 equals 0. So the first thing you want to do is you want to get it in the correct form. So remember that constant needs to be over on the right-hand side. So I'm going to subtract the 1 over to the other side. In the next step, well, before we get to the next step, we still actually haven't gotten the correct form yet. Remember, in the correct form, the x squared is by itself. Here we have a 2 in front of the x squared. So what we're going to do is we are going to divide both sides by 2. So this leaves us with x squared minus 3x on the left and negative 1/2 on the right. Next, we're going to determine what b over 2 squared is, and then we'll add it to both sides. So over here on the side, I'm going to write b over 2 squared. Now b is negative 3, so negative 3 over 2 squared, which is equal to 9/4. Now if you prefer, you can absolutely use this in decimal form and work in decimals. So we're going to add 9/4 to both sides. And now the left-hand side is a perfect square, and the right-hand side is still a constant. So let's talk about how we would go and write this as a perfect square. So as a perfect square, that means that what's inside the parentheses should be exactly the same in both factors. Now, what goes inside? The easiest thing I find, the easiest trick that I use, is I look at what b over 2 is equal to before squaring. So in this case, that would be the negative 3 over 2 that was inside the parentheses before it was squared. So I can write this as x minus 3 over 2, x minus 3 over 2. And then I'll combine the negative 1/2 and the 9/4, and that is 7/4. All right, on that left-hand side, now I'm going to write this as a perfect square, so x minus 3/2 squared. Now we're almost done. We still have to take the square root of both sides and then simplify. So if we take the square root of both sides here, I'm left with x minus 3/2 equals plus or minus the square root of 7/4. And I still need to get x by itself, so I need to add 3/2 to the other side. And now we do have two answers here. We do want to simplify it as much as we can, so I know that I can take the square root of 4, which is equal to 2. So this is plus or minus the square root of 7 over 2 plus 3/2, and if we want to write that as one fraction, we can. And so that is our answer. Lastly, our last method of solving quadratic equations algebraically is to use the quadratic formula. Now, when you use the quadratic formula, it is simply using a formula and plugging in values for a, b, and c. Now, what's nice about this is that if you're unable to factor something, or if you're unable to take the square root of both sides, you can absolutely just simply use the quadratic formula if you can identify what a, b, and c are and plug it right into the equation. So in our example, we have x squared plus 3 equals negative 8x. Now make sure before you start identifying a, b, and c that you move everything over to one side. So we have x squared plus 8x plus 3 equals 0. Now a is equal to 1, b is equal to 8, and c is equal to 3. So I'm going to plug those numbers into the formula. So that would be negative 8 plus or minus 8 squared minus 4 times 1 times 3 all over 2 times 1. Let's simplify this as much as we can. I would start with what's inside the square root. So that would be 64 minus 12, which is equal to 52. Now, if we are trying to simplify the radical, we can take out a 4. So square root of 4 is equal to 2, and 4 times 13 is equal to 52. So that leaves us with 2 root 13. So this is negative 8 plus or minus 2 root 13 over 2. And now we can actually divide both of those by 2. So this is equal to negative 4 plus or minus the square root of 13. And that's our answer from using the quadratic formula. So we've gone over a number of different methods of how to go about solving quadratic equations. We first started by talking about how do you solve graphically. What does it mean? What are you actually looking for? You're looking for those x-intercepts. And then without graphing, we went over 4 different types of methods, starting with factoring. Then we did taking the square root of both sides, which is when you only have an x squared term, you don't have an x term. Completing the square, which is when you move the constant over to the right and you have x squared plus bx on the left, and you use b over 2 squared. And then the last method we just did is using the quadratic formula, identifying a, b, and c, and plugging it right into the formula.